Remember yesterday we were trying to look at terms and decide if they were like terms and then add them together. So if you look at number 37, we have 4p plus 2p squared minus 2p and then plus p squared. So when I look at a problem, the first thing I do is kind of just look at the entire problem, and I'm noticing the coefficients. That was a term we talked about yesterday, the numbers in front. The last one doesn't have a number in front. It just says p squared. So I'm going to place that 1 in front so that I know there is a number there. And then we talked about like terms, and those are the ones that have the same letter and exponent. So Emma, can you tell me what would be the like terms in number 37 that I have up here on the screen? Which ones would be the same?
Would it be 2p and 2p?
So I understand you're thinking they both have a 2, but if you look at the letter next to them, so look at that 2p squared. Is there another one that has a p squared with it?
Oh, 2p squared and then the 1p squared.
And the 1p squared, right. So we're going to add those two together. And you're really adding the numbers in front. So if you need to write information on the side, we're taking 2p squared and 1p squared. Those are my like terms. So we're going to add those together. You're adding the numbers in front. So that makes 3p squared. That's really what you're doing when you're combining like terms. You're adding the numbers in front. So that means the other two that are left just have p's. So notice the difference. P squared is a like term, and the ones that have the p's are like terms. So the letter and the little power at the top, that exponent, they have to be the same. So when I combine these together, I'm doing just the numbers, 4 minus 2, and then the letter just kind of tags along for the ride. So if I look at these, my end answer is 3p squared plus 2p. So my end answer is just combining those together in a linear format or in a line. So no, you don't have to show these steps here that I have, but that's kind of the thought process that you should be thinking about. Maybe you just box them or underline them, and that's fine as well. So again, I combined the like terms. The p squareds, I added the numbers in front, and I got 3. And then the p's, you took 4 minus 2, which makes a plus 2, a positive 2. So this should be your end answer for number 37. So we're going to try and do that same thing for number 45. Looking at number 45, there are parentheses in this problem. And we need to kind of focus on those parentheses first and try and think about what to do with those. Michael, what do you think we should do with those parentheses?
Just distribute the 5.
And what do you get when you distribute the 5?
5h squared plus 5h.
And then what else would you do?
Multiply the -3 with the h2 and -2h.
And what's that make, Michael?
-3h squared, and then 6h.
Perfect, yeah, and it's a plus 6h. Nice job. All right, so that would be the first step. We have to distribute. And then the second step is to look to see which ones are the like terms again. So just like we did above, it has to be the same letter and exponent. So I need to hit both pieces there, same letter and exponent. So Nathan, which would be like terms here? What do you see as the like terms?
5h squared and 3h squared.
Yeah, and when you combine them together, we have a 5 and a -3. What is 5 minus 3, Nathan?
2.
Good. So again, the h squared comes along for the ride. You're combining the numbers in front. Nathan, how about the other two terms?
5h and 6h.
And what do you get when you combine them together?
11h.
Perfect, nice job. So here's my answer. 2h squared plus 11h. I can't do anything else with them because they are different. One is an h squared, the other one is an h. So they're not like terms. So that's what we talked about yesterday in class, and showing a little bit of work, just minimal, but maybe boxing or circling the ones that are the same or underlining them. I put little squigglies underneath them, and then combining your like terms. So before Mr. King goes over the notes with you, are there questions that I didn't answer from the homework last night that you want to go over? Because we can go over any other questions that you have from the homework. I just chose those two problems based off of the ones that were assigned. Anytime that you have a question, remember you can always send it through that chat because it just comes to me. Okay, so Mr. King, I'm going to turn the screen over to you.
If you want to open up your notes packet, we're going to continue on section 1.3. We're going to start with example 4. We did sections A and B yesterday, parts A and B yesterday. We're going to continue on today through the notes. So we're going to look at example 4, part C, where it says 18 minus 4 times the quantity x minus 2. So if everybody wants to come here in their notes packet. Okay. So again, what we're going to look at is we're using PEMDAS. So we do have parentheses. We have the x minus 2. If you notice in front of the parentheses, you cannot combine the x or the 2. So now we go to exponents. We do not have any exponents, but we do have some multiplication. So if you look, we have 4 times the quantity x minus 2. So we're going to go ahead and distribute the 4 through. When we do that, we'll have a negative 4x. It's negative 4 times x, which will give us negative 4x. And then lastly, we have a negative 4 times a negative 2. Negative and negative gives us a positive. 4 times 2 is 8. Any questions on that first step there that we did using PEMDAS? Now we're going to use our like terms. Anytime we're writing an algebraic expression, we always want to put the highest power variable first. In this case, we only have one, which is the 4x. But if we look here, we could combine our constant terms, which are 18 and an 8. So we'll bring the 4x out front. 18 plus 8 gives us 26. And our final answer will be negative 4x plus 26. Anybody have any questions on that? All right, let's look at example D. And again, we're still going to use PEMDAS. Parentheses, exponents, multiplication and division, and addition, subtraction. Now looking through the test, there's make sure that when you get to the multiplication and addition subtraction, that you're working from left to right, okay? It does not mean multiplication first. It's working from left to right. So multiplication and division are equal in PEMDAS. All right, first step, we're going to go ahead and distribute through. The 3 goes to the 4 minus x, and then the 2 will be distributed to the x minus 7. I can have a volunteer to help me answer what this is going to look like. What would 3 times 4 give us?
12.
12.
12, good. And then if you want to keep going, 3 times negative x.
Negative 3x.
Awesome. Negative 3x. Now we're going to distribute the 2. 2 times x is going to give us 2x. 2 times negative 7, negative 14. Now we look at combining like terms. We have a negative 3x and a positive 2x. And then we also have a 12 and a negative 14 as our constant terms. So first, I'm going to go ahead and combine the negative 3x plus 2x. What do we get there? 2x minus 3x or negative 3x plus 2x? Jason, what do we get there?
Negative 5x.
No, not negative 5x because it's that's a positive 2x. So it'd be negative 3 plus 2 more of it. So in
Negative
this
1.
case, good. Negative 1x, or we would just say negative x. Next, we have 12 minus 14. What do we get here?
Negative 2.
Awesome. So negative x minus 2 would be our final answer. Questions on that? Okay, we have a word problem here. I'll go ahead and read this for you. It says a boat rental company charges customers for rowboats as shown in the advertisement. There's a 1 hour minimum rental time. And if you look at the poster here, it says that the first hour is $13, and each additional hour is $6. So that first hour is going to be a one-time fee just to rent it. Write and simplify an expression that gives the total cost to rent a rowboat for H hours, where H is greater than or equal to 1. Now, when we're working through this, what do we have? What's the initial cost? It's always going to cost how much to rent a rowboat, no matter how long you're in there.
13 the first hour.
13. Awesome. Now, are we going to be adding to that $13, or are we going to be taking away from that $13?
Adding.
Adding.
Perfect. We're adding to it. And we're definitely adding $6 for each hour. Now, the issue we have here is that we already got charged for the first hour. So we can't just put 6H. That's not correct because we're going to get charged twice. So what we got to think about is that first hour needs to be taken away from our total number of hours. So we're going to use parentheses, and we're going to have our total number of hours minus that first hour that was already charged. Does that make sense?
Yes.
Okay, and again, I'll just try to explain one more time that that first hour is at $13. We need to make sure that that's accounted for. So you take that away from your total hours. That's why we use H minus 1 in parentheses. Now it says find the total cost of renting a rowboat. Well, all we do here is we plug in. We take 13 plus 6 times, and then we're going to plug in 8 minus 1, and now we just use PEMDAS. 13 plus 6 times 8 minus 1 gives us 7. 6 times 7, somebody have that for us?
42.
Good, 42, and then our final answer would equal
55.
awesome. $55. Are there questions on that word problem? Okay, we're just gonna do 3 more and we'll move on for today. The first one on checkpoint says identify the terms, coefficient, and like terms of the expression. So I just want to go ahead and make sure that we have our vocabulary down. The term terms is every single one of these is its own term. 4x cubed is a term. Negative 5x squared is a term. Positive x squared is a term. Negative 9x is a term. Negative 9x cubed is a term. And 7x is all terms. Does that make sense? Or questions on the vocab word terms? Okay, next we're looking at coefficients. If we remember the definition for coefficient, a coefficient is the number in front of a variable. So if we have 4x cubed, well, in this case, the coefficient is going to be the number in front, which is a 4. So we look through here. Can I have a volunteer to read off all the coefficients, working from left to right?
4, -5, 1, -9. Or my bad, I didn't mean to get that fast. And -9 and 7.
Perfect. So reading across, very good, Mr. Foskey. We had 4, -5, 1, -9, -9, and 7. Those are our coefficient terms. Next, we have our like terms. So we're going to start with the highest exponent. So can somebody tell me which terms have the highest exponents?
Uh, 4 and 9, -9.
We have 4x cubed, and we also have -9x cubed. If we combine those, 4 minus 9 will give us -5 x to the third power. Our next highest one would be we're looking for squares. If you notice here, we have -5x squared and a positive 1x squared. -5x squared plus 1x squared would give us a -4x squared. And lastly, we would have our x to the first power. We have -9x plus 7x, which will give us a -2x. And those are how we combine our like terms. Questions on any of the vocabulary we had for this unit? So again, terms, coefficient, and like terms. Okay, just 2 more quick ones, and then we'll be done for today. We have number 5 I'm going to look at. What we want to do first is distribute the 2. 3 plus 2x. 2 times 4 gives us 8. Now we're going to combine our like terms. We start with the variables first. We'll bring down the 2x. We can combine the 3 and the 8. 3 plus 8, 11. And make sure you guys are showing work for this. I know it's just minimal work, but just like the work I showed there, make sure you get full credit on homework, tests, and quizzes. Last one we're look at is number 7. Again, we're going to distribute 3 through to the x minus 1. And now when we look at this next part here, what's in front of, you see how it's a negative, the quantity x minus 9? Can somebody tell me what number is there? It's not listed, but what number is in front there?
1.
1. Excellent. Oops. So that's just like having a -1 there. We'll distribute that through. So now we'll start with the first term. We have 3 times x is 3x. Oops. 3 times -1 would be -3. Now we're going to distribute the negative. Another way to think about this is a negative means opposite. Everything that's in the parentheses is going to be opposite of where it is. So it's a positive x. The opposite of that is a negative x. It's a -9. The opposite of that is a positive 9. So either way you want to think about how to do it. Now we're going to look into combining our terms. We have our x's, and then we also have our constant terms. So I'll start with the x's. 3x minus x gives us 2x. And then negative 3 plus 9, or 9 minus 3, will give us a positive 6. Any questions on any of the examples, terminology, or anything we went over today for section 1.3? Chase, nice job on answering questions today.
There we go.
Thank you.
All right, so your homework today is a worksheet, and this is exactly what the assignment looks like that's posted in Google Classroom. You can see that you don't have to do the whole worksheet, so you're doing 3 to 23, just the odd problems, and then only number 29. And I'm going to click on the worksheet so you can see what it looks like. So you see that there is space underneath for you to write. Just try and be as neat as possible if you are using the worksheet and you're using Notability or the Adobe app. So this is exactly what the worksheet looks like. If you're doing it on a separate piece of paper, great, that's fine. Just write down the problems. And then you have 29, the car wash problem to do. So one word problem. We're not doing all of the word problems. So as always, we are here for the next 15 minutes. Class goes till 11:25. That you can stay on the Zoom session and you can work through the homework and ask questions as you kind of approach a problem and you're not sure what to do. Or you can choose to leave and just use this time to get your work done. But hopefully within the next 15 minutes, you should be able to have most of this worksheet complete. Does anyone have questions? Okay, nice job today. Thanks for joining us.
Thank you.
Thanks.
Thanks,
See ya.
Have a good one.
See ya.
Bye.